Hi everyone, so today we're going to solve question 8 of the 2015 Math A-level paper, and this is paper 3, A-level. Okay, so we have a classic differential equation to solve, and we are given that dx d theta equals x plus 2 sine squared of 2 theta. So when you see a square trigonometric function, you should immediately start thinking about identities. And we're given a boundary condition, so remember, if it's a first order, then we need one boundary condition, and we are told to solve it, so we want the solution, and calculating the value of x when theta is pi by 4 is also required. Okay, so they want us to give the answer to 3 significant figures. Okay, so how do we approach these questions? Well, the first thing to know is that this is a equation in which we can separate variables. Okay, so let's get going. So I rewrote the equation here, so that's the exact same equation as in the question, and this is a squared trig function, so we need to use an identity because we know that we're going to integrate, and so I'm using an identity here. And the identity I made use of is, I'll write it here, is sine squared of a equals to half, that's a 2, 1 minus cos of 2a. So using that identity, we plug that in for sine squared 2 theta, so we get 1 minus cos 4 theta over 2. So that's this term right here. So dx by d theta is x plus 2, 1 minus 4 cos of theta divided by 2. So now we integrate by separating variables. So we divide by x plus 2, and we multiply by d theta on both sides, integrate, and we integrate from 0, and this is a way to fit in the boundary condition given from the start. So you don't need to account for a constant c and then solve for the constant c using the boundary condition. You realize here I'm using a dummy variable for x, so this is a dummy, and the same for theta prime, right? So you do the integral, so the left hand side becomes an ln term, because if you differentiate ln x plus 2, you get 1 over x plus 2. And again, the right hand side, you carry out the integration as usual, and you can check your answer by differentiating the right hand side here. So if you differentiate this right here, then you get theta minus cos of theta, sorry, cos of 4 theta, so this is correct. You plug in the boundary condition and you end up with this relationship here. So there we go, we've solved our problem. So ln x plus 2 is equal to theta over 2 minus sine 4 theta over 8 plus ln of 2. So that's our solution. So now we need to find the value when theta equals pi over 4. So sine of 4 theta will be sine of pi, and we know that sine of pi is 0. So sine of pi is 0 because the sine function looks like this. And you should know this when taking exams, because these are, you should know the graph of cos, sine, tan, 1 over sine, which is cosec, 1 over cos, sec, and 1 over tan, which is cotan, cot. Okay, and then sine of theta. Well, this is pi. So then sine of 4 theta, when theta is pi by 4, would be 0, right? So there you go, and you plug in the answer here, and this is what you need to put into your calculator in order to get the right answer, and this should give you x equals to 0.962 to 3 significant figures. Okay, that's it for